Well, if you're out there, let's put your name on here so I can keep a roll. Things have been down in terms of the internet, and they still may be down. Let's see how it is. Hello, Lace, Brianna. Glad you guys are still breathing after the storm came through. Hey, Brooke, Nathan, Heather, great. Good to see you all on. Well, we had a hard time this morning trying to teach. Couldn't do it. Just kept breaking up. Hey, Jordan, Kenya, glad you're all right. Hey, Jessica. Well, came through the winds last night and the rain. Just fine. A few branches down from the trees, but other than that, we're in good shape. Hope you are. Hope your house is in good shape. You like to sleep through those storms, don't you? Yeah, my wife and I enjoy hearing those storms. Hello, Shakira. Yeah, I thought I responded to your email. The computer here's been going kind of off and on, but I think I responded to it. What was your question that you had? Tell me what your email said, Shakira. Well, number one, you came okay in terms of the accident, didn't you? Good. I'm glad you came out all right. Now, I know you took the test. If you have a question about the test, you don't want to just say make it public with everybody else. You can shoot me an email again and ask some specific questions if you have them. I'd be glad to try to answer them. That's fine. When we get through here today, just shoot me an email and I'll be glad to respond to you. Anybody else out there that hasn't signed on yet? Stephen, good, good. And your fourth test is going to be on chapter 10 and chapter 11. Now, let me ask you a question. How far did we get into chapter 11? Oh, that's wonderful. So we got all the way over there. We talked about neurotransmitters such as dopamine. Well, let's see. You said figure 11.3. Oh, that's as far as we got. Well, we didn't get as far as I thought we had gotten. I know we had some times where it was just tough to have a continuous audio program. Are all of you hearing my voice pretty consistently now? Is it not breaking up on you? Let's see. Are you looking at the table of neurotransmitters? So we actually pretty much finished that section, didn't we? We talked about the membrane potential, resting membrane potential, and depolarization and repolarization. Oh, that's good. Can all of you hear me well? How about the rest of you? Is it coming through pretty well? Good. Hey, Paul. The table she's talking about, Stephen, 11.3, is on page 415 in the textbook. Okay, now I see you've got yes and yes and yes. So everybody feels pretty comfortable about the membrane potential and the sodium potassium pump, how it creates that membrane potential. Do you feel comfortable with that conduction? Okay. This morning I was trying to put this on. You probably can't see it worth a hoot. But there you go. You might make it out. Trying to put out a study guide this afternoon for you. So you'll focus on those things on the study guide. That's correct, Kenya. You want to know those chemicals as neurotransmitters. So as you look on that table 11.3, I think we checked off acetylcholine, which you're familiar with in terms of the neuromuscular junction. And then the biogenic amines, you see norepinephrine, epinephrine, dopamine, and serotonin. So those all come from amino acids. So when will test 4 be? We can do test 4 next Monday. Let's do it next Monday, okay? I think you have all the notes. Did you receive anything from me in terms of, besides a study guide, which I haven't gotten to you yet, but did you also get some sort of a Word document from me about the nervous system, about the membrane potential, resting membrane potential, and so forth? Did you get a Word document on that? You did get that Word document. Great. Thank you, Charkira. Thank you. So if you got it, that means other people got it too. Good. That's great. Okay. So you want to have it next Monday or next Wednesday? We can do it next Wednesday. I'm looking for something that Mr. Malachowski sent me that could help you. I thought I wrote it down somewhere. Hang on just a second. Uh-oh. Okay, let me see if I can draw up this email from Mr. Malachowski. He had some good thoughts on how to deal with honor lock. So hang on tight for just a second. This has been one frustrating morning. Mr. Malachowski sent me something, and doggone if it hasn't disappeared. Oh, my. Very frustrating. Well, I will try to send that to you. I'll have to get him, ship it back to me again. Oh, my. This email is different from what I have at school. Oh, challenging, challenging, challenging. Man. Okay, I'll just try to find it and get it to you. Oops. And get it to you this afternoon. Crazy stuff just disappeared on here. Some of my stuff, even on my little flash drive where I keep information, working on it, all of a sudden just disappears. I do not know what has happened, but it sure is frustrating. Go ahead, Stephen, and ask your question. You know, as far as I know, it will. As far as I know, that if you make higher than some of the grades on your tests, you can count that final exam twice. A little bright sunshine in your day there, no doubt. Okay, now the last, I think we'll have time to do a little bit of this. What we want to do is you'll take the fourth test next week, but now and Monday, what we'll do is we'll look at chapter 15. Chapter 15. Well, it's frustrating to have stuff disappear on your email. So chapter 15, we'll look at a little bit on the eye and the ear. Now let's see, where's that red pen? Chapter 15 is on page 538. Now you see how you move this thing and all of a sudden the picture of me is gone. I don't know if it's gone for you. I don't think it is, but it's gone for me. So let's look on page, that's 538 is where it has special senses. And what we want to do is look at the ear, the eye and the ear. So the eye starts on page 546. So as you look on page page 546, you see they start off with the accessory organs of the eye. Got a person's eye down there, and they also have an illustration on the same page. Most of you understand the functions of some of these accessory organs. So you can highlight or underline the eyelids. And if you look down into that first paragraph about the eyelids, come down to the second line, you'll see that, and you already know this, but this is just part of the functions of these accessory organs. You see they block objects from entering the eye. And then the second thing is they distribute tears over the surface of your eye. Now, if you look at a couple of lines down, where you see figure 15.8b, that's in the paragraph. Don't go look for that figure at this point, but just look at the sentence after it. Modified sebaceous glands called tarsal glands are located within the tarsal plate and secrete oil to prevent the eyelids from sticking together. How many of you have had your eyelids stick together? We produce too much of that. It creates a problem for us. Again, you come back to homeostasis, don't you? And so you have eyebrows and eyelashes in the next section, and they serve a protective function, as you see. The hairs on our brow prevents perspiration from running into your eyes. Not a perfect piece of equipment, is it? Because you probably have had sweat come into your eyes. And your brow reduces the glare as you look up on the next page in bright light. You see that the eyelashes are stiff hairs. We already know that. They are richly innervated by nerve endings. You see that sentence? So a little touch causes you to blink. It's for protection. You still hearing my voice? Everybody okay? Still coming through steadily instead of breaking up? Is it still okay? Good. Okay, that's great. Thank you, ladies. Now you come to a section where it says the conjunctiva. And you see this, that membrane that covers, not only it says the posterior surface of the eye, then it turns back to cover the anterior surface of the white part of the eye. Hang on just a minute. Got a phone call here. Yes. Hey. Thank you for your patience. What lesson are you in? Because I can't find it. Let's see. Do you have your textbook there, Brooke? We're on page 547. It shows you 15.9. Now, Kenya says 15.4. She may have a different edition. But it's on page 547. And there's actually, it's under 15.4 is the section of the chapter. Anybody else using the e-text that they could help Brooke find that illustration of the eye and about the conjunctiva? Okay, hang on just a minute. Let me see if I can find it on D2L for just a second. Oh, you think you got it? Good. Okay. So do you see a little heading that says conjunctiva? It's one of those big headings over a small paragraph. Good. Okay, that's great, Brooke. Okay, so the conjunctiva lines the dorsal surface. Now think about that. You got your eyelid here, and the dorsal surface would be the one on the backside that's actually rubbing your eye. This would be the anterior surface where my finger is, but on the other side is the dorsal surface. So that conjunctiva, or tiva, however most people say conjunctiva, we'll have to look that up, won't we? I know they go conjunctiva. You hear it a number of different ways, so don't let it fool you. So it lines the back of the eyelids, but then it folds to the front. You see it turns back on itself as the bulbar conjunctiva to cover the anterior surface of the white part of the eye. Any of you guys ever had pink eye? You look at the last sentence there in that little paragraph. Yeah, it's not any fun, is it, Kenya? Itches, very irritating. You don't die from it, but it's very irritating. Can be caused by a virus, can be caused by a bacterium. So, but it helps to protect the eye to some degree. The next paragraph has what they call the lacrimal apparatus. So they're talking about a number of pieces that are put together to make the apparatus. So as you see, the first thing they talk about is the lacrimal gland, which we call the tear gland. Now look at the last sentence. When stimulated by autonomic neurons, that means you don't have any control over it, right? Tiny ducts release tears and mucus into the conjunctival sac to lubricate and wash away dust and debris. And then you see it says, blinking sweeps the tears medially. Now look, as you look at the picture, your tear gland is out here. So it's in the lateral aspect of what we would call the orbit, O-R-B-I-T, just like the orbit the Earth goes in around the sun. This hole called an orbit is where your eye fits, but out here on top of the eyeball, right over here or over here, that's where the gland is. So the tears are released here, but every time you blink your eye, the closing eyelids push the tears medially. You can see that said that in that paragraph. Just want to point it out. Sometimes it's easier to point it out. Across the surface of the eye, and notice they drain into a series of passages into the nasal cavity. Tears first enter the lacrimal puncta. Puncta means point. Those are tiny little holes right down here and up here on the upper lid too, Tears go in these tiny little holes, and then they eventually come into your nose. So they wash the surface of your eye, and then that also helps with bacteria. One of the things people don't think about very much, but it's true, is that in the air there are bacteria. In the air there are viruses. In the air there are spores of molds, and we come in contact with them all the day. You can't help but do that, but you don't get a lot of them on there. But those tears wash them into your nasal passage. And remember, you have cilia in your nasal passage, and the cilia push the mucus that have caught the bacteria, the viruses, the fungal spores, and they push that mucus down the back of your throat and down into your tummy. It's a flushing mechanism. Most of us, when we think about flush, we think about hit the handle and it's out of the house. But we have several mechanisms in the body, and this is one of them, where you flush the surface of your eyes. Now, as you follow the paragraph, you see it says the puncta. This is the third line up from the bottom. The puncta are continuous with the lacrimal canaliculi. You heard that back in the bones, right? Connect osteons together, little cavities, little canals. Small ducts that empty into the lacrimal sac. Drains, and look at the next paragraph, next column, drains into the nasolacrimal duct, which travels to reach the inferior nasal meatus. We haven't really talked about that, but it gets it into your nasal cavity. Now, some of you may have noticed this. If you look in the second paragraph on page 547, if tear production increases in response to debris, to allergens, or emotions, you end up with a runny nose and excess tears that spill over on your cheek. Now look at the last little bit of that paragraph. It says the connection between the nasal cavity and the eye can be a two-way street. Pathogens can travel from the nose to the eye. I do not have any data on how often that occurs. It's usually some picking it up some other way, or some infectious agent causes a problem, resulting in conjunctivitis or a painful infection of the nasolacrimal duct. Now, I don't know if you've ever seen people do this, but this is crazy. The last three lines, it also explains from the anatomical perspective why people can compete in contests to see how far they are able to shoot milk out of their eyes. They can squeeze these ducts, and they have a contest. Can you believe that? A man can make a contest out of anything, can't he? Do you have any question about the tear glands, lacrimal glands? It's crazy what people will do, isn't it? At least we think it's crazy. They think it's fun, I guess. But anyway. Now let's look in that same page, 547. and you come down to the heading called Extrinsic Eye Muscles. Of course, extrinsic means they're outside. Maybe they take a day off to do it. Maybe they practice at home and then they take a day off to do it and see who can win one of grandma's apple pies or something. So these are muscles on the surface of the eye that enable us to roll our eyes. You've all seen people roll their eyes when they think something's dumb. Or you may have control over your muscles on the medial surface of both eyes, and you can cross your eyes. Anyway, you want to know these 4 muscles. And you see them listed about the middle of the way down in that paragraph: the superior, inferior, lateral, and medial rectus muscles extend from the. You just need to know the muscles. We're not going to worry about their origin and their insertion and so forth. Look over on the next page. And you have a couple of good pictures about the muscles that control the movement of our eye. So as you look at the picture on the right, which is probably going to mean the most to you at this point, you see over on the right-hand side, or let's look at we're looking at the lateral view of the left eye, and you look up at the top and you see superior rectus muscle. Now rectus, you know that like rectum, okay? Means. So superior, of course, means on top of the eye. Rectus is straight, and you can follow that little line from the word there onto the diagram, and you see that muscle. So when you look up, that's what's contracting, the superior rectus muscle. You come over to the right of that, on that lateral view of the left eye, and you see at the top the lateral rectus. Superior is on top, lateral is on the side. And of course, lateral means it's out here. So when you look to your right, both of your eyes do that, don't they? So the lateral rectus over here is relaxing, but the medial rectus over here is contracting, so it pulls that eye to the right also. So we can move both eyes at the same time. You guys ever seen one of those little, let's see, what are they called? It's a kind of a reptile, and his eyes can go in different directions so that he's looking all around in different ways. He doesn't have those eyes coordinated in the sense that you and I do. He may be able to do that, but he has the ability to have the left eye look over to the left side and the right eye look to the right side. Pretty neat little creatures. Chameleons, that's what they're called. They're called chameleons. So each eye has a superior rectus to make the eye go up, a lateral rectus to move it to the left. That's it, Heather. You got it. You notice as you come into the middle again, between the two illustrations, you look at the bottom and you see inferior oblique and inferior rectus muscle. Just look at the inferior rectus muscle now. It's obviously attached to the inferior of the eye. And so it helps you look down. You can keep your face steady and you just look down and you can see stuff that's, a couple of inches or so out from your face. It's not under your chin. You can't see under there, but you can bring your eyes down and you can see a little bit of what's on the table in front of you. So that would rotate the eyeball inferiorly. So as you look at the picture to the right, to the left, excuse me, you see in the middle, you see the medial rectus, and you see a lateral rectus over there to the upper left of that figure A. And you have an oblique muscle. Now, there are a couple of other muscles in there that you can look at. I'm not going to hold you accountable for it, but gives you an idea of how you and I can move our eyes all around. So, having said that, let's move to page 549, and actually it'll probably be looking at the diagram 1511 on page 548. So let's look on page 549, and you're in the first column, and you come down to where you see it says the eyeball. So as you come down into that column that says the eyeball, you see layers of the eyeball. So you locate, first of all, what's called the fibrous layer, outermost layer, two parts, sclera and the cornea. So as you look to the picture, 1511, you see over to the left, layers of the eyeball. And you look up at the top of that bracket. That's where we want to look at this point. And you see the fibrous layer, the sclera, and the cornea. The sclera, which you see is that outer coating away from the cornea. We call it the white of your eyes. Some of you maybe who've taken a little bit of history, you've heard people say don't shoot until you see the white of their eyes. That means they're close enough to hit them. In the paragraph where it says fibrous layer on page 549, you see right after figure 1511, that little parenthesis there, says the sclera, the white part of the eye, and you don't have to know that it covers 5/6. It just covers a whole lot, like about 80% or so. Come on down about 3 or 4 lines. It says the sclera's numerous collagen fibers, strong fibers, right? Just like in bone, allow it to resist deformation from external and internal forces and maintain the shape of the eye. So that seems to be the purpose of it. It's pretty tough tissue. Have you started the nervous system in the lab? Have you started the nervous system in the lab yet? Did you guys look at a model, or did you get to look at a sheep eye? Or maybe a cow eye? Did you look at a cow eye or a sheep eye? Or did you not look at it? Model or specimen? Hello out there. Did you look at a sheep eye or did you look at a model? Oh, maybe you're not going to have that, or maybe you're going to have it a little bit later because you got a couple of weeks that you still got to cover some material. Okay, so maybe you'll see it. But anyway, when you may get to cut that eye, and you'll find that that tissue is pretty tough. Come down to the next paragraph. The sclera is continuous with the cornea in the anterior of the eye. The cornea is translucent, so it allows light to come into the eye. And notice it also plays a role not only in just allowing the entrance of light, but it bends the light a little bit, which helps with your sharpness of vision. Some of you probably wear contact lenses. They used to tell you not to sleep in them, but you've got some that will allow, they call them gas permeable, I think, and that allows more oxygen in there, so that's better health for your eye. But you want to be real careful with them. Sometimes people have not washed them properly, and they can end up with a bacterial infection or viral infection. Not fun. So that takes care of those 2 outer layers. They're actually one continuous piece of tissue arranged a little differently. And that's kind of interesting, isn't it? They're, in terms of the sclera, they're randomly scattered so that you can have compression or pulling in all different directions. But in the cornea, those collagen fibers are like dense, regular connective tissue. Now you want to go back over to page 548. Again, you're looking at this. What kind of view of the eye is there to make you use those terms? What kind of a view? What sort of a section is it? Remember the sections you had to learn at the beginning of the semester? One goes like this, one goes, oh, that's right. Did you read that, Akenya, or did you know it? It's down there in the bottom of the page. I just wondered if you looked at it or whether you recognize it as a sagittal section. Yeah, we'll call it a mid-sagittal. That's right. So you come down on the left-hand side. We're leaving the fibrous layer, and there you've got, next you've got the layers of the eyeball. It says vascular layer. Vascular means it's got blood. And notice what it points to. Your iris. Don't call it your Irish, okay? Remember, Irish is a term describing something in Ireland. So you have the iris. Iris is also a flower. It's an amazing structure, this thing. And then you see ciliary body. If you want to, you can put a little note under there. That's a muscle. Its ciliary body is a muscle. Got visceral muscle. Now, where you see ciliary body, follow the line down there at the bottom, follow the line under vascular layer, and you see it's pointing to a little red tissue, which is visceral muscle. And you see these little strings that go up from the ciliary body. And they attach to the lens. They don't attach to the pupil there. Okay, we're talking about just the lens at this point. The lens is very flexible. It can get long, it can get short, it can get rounder, it can get more elongated. I wonder where all that noise is coming from. Now go straight up through that gray structure that's marked lens. We'll talk about the pupil in just a moment. And then you come up to some more of those strings. Those strings are called suspensory ligaments. So you want to know those. The suspensory, you suspend something. I'm suspending this pen. Of course, you can get suspended from school too. It means you got to hang out somewhere else, doesn't it? So suspensory ligaments are attached to the ciliary body. So depending on what we're looking at, and this is just another one of these amazing things, that we take for granted. You know, we just look at something and it's automatically in focus, isn't it? Because the image hits our retina, which we'll get to a little bit later, in different ways, depending on how far you are from an object. But there are obviously some sort of message that comes from some other tissue that causes the ciliary body to either relax or contract. So you change the shape of the lens and it focuses it on the retina, which we'll talk about a little bit later, the screen. And you see clearly. You see the object clearly in focus. Sometimes some of us have to have a little help, don't we? Depending on the length of your eyeball, how long it is, front to back, you can either be what we'll talk about it a little bit later, but it's either nearsighted or farsighted. Because your eye is not the perfect sphere that it should be. When you're either nearsighted or farsighted, your eye is either too short or too long for your ciliary body to change the shape of the lens so that you see clearly. So when your eye is too short or too long, we have to get a pair of these that helps us to some degree overcome the fact that the eyeball is too long or too short. We'll mention that a little bit later when we get a little further into it. Now we talked about the ciliary body. Now you see where it says pupil? The pupil is the opening in the iris. The pupil is the opening in the iris. It's void. It's empty. Lets light through. Isn't that interesting? They call little children pupils because they're empty. I'm empty in some aspects of my life too. I want to fill it with this knowledge. So the iris is that part of your eye that somebody looks into your eye and says, "Oh, I love your blue eyes. I love your brown eyes. Oh, I like the green of your eyes," and so forth. And we have these different colors, don't we? Yeah. Now, I want you to look over on page 549. Page 549, you're in the second column. We're still talking about the iris. I want you see number 3, it says the iris, colored portion of the eye, an extension of the vascular layer, just anterior to the ciliary body. We're not going to get into why you have various colors, but it's great to have different colors, isn't it? Come down to the next paragraph, if you would, please. The iris, it says the iris surrounds the circular pupil, an opening through which light enters the eye. the iris contains two muscles. You don't have control over them. They do it automatically for you, which protect the eye and improve vision by controlling how much light passes through the pupil. The pupillary sphincter contracts, allowing parasympathetic following parasympathetic stimulation, and it constricts the pupil to reduce the amount of light entering in the eye. Look at the last sentence before we go to the next page. The pupillary dilator contracts following sympathetic stimulation. Its fibers are arranged in a radial pattern, not a circular, but a radial pattern, which causes the pupil to enlarge to permit the entrance of light into the eye. Now, one of the things that you want to keep in mind basically about the autonomic nervous system, there's a parasympathetic branch, there's a sympathetic branch. Usually the sympathetic branch will help you get ready to flee some sort of a problem or fight back, whereas the parasympathetic branch tends to make you relaxed. Your GI tract is working more, it's digesting food and so forth. Your skeletal muscles are relaxed. So whenever you get scared and you're looking at it, the iris tends to contract sympathetically, and that muscle opens the pupil so you can see more of, can we say, your enemy or whatever is scaring the daylights out of you. And you don't have to think a thing about it. You're already wired for that to happen. Okay, we're going to stop right there, and we will take up on page 550 with the neural layer called the retina. Don't call it the retina. It looks like it ought to be said that, and somebody might take a name like that and say, my name's Retina. Well, you could get away with that, you know, be creative with it, but retina is the way we say it in the medical profession. Do you have any questions? Okay, well, I'm going to get started. I've got some of your study guide ready. I'm hoping that this computer is going to work and not play around like it did this morning. Sometimes the cursor would stop and then it'd go up 4 lines. Kind of bugs you, you know. You'd like to get some work done. Okay, no questions? Sure. I'll be glad to look at it. Okay. Anybody else? All right. Well, this has been kind of a pleasant surprise, hasn't it? No buffering, no freeze ups or anything like that. It was freezing up this morning at 8 o'clock when I had to meet the micro class. Anyway, you guys have a good evening, and look for your study guide. All right. Hasta la vista.